We're in another aspect for mathematics, we'll be talking about adding them. So we don't use the plus sign, we use that particular symbol in sets to mean the union of the subsets, and it means joining them back together to give us what we started with. Okay? Now, if we're not talking about the union of the set, and we're not talking about the complement of the set, then we can be saying we have, wherever we have two subsets coming in, so that instead of saying,
be sure that you're working in the same units of measure when performing calculations. If a problem involves inches, feet, and yards, be sure to make the appropriate conversions so that all your values are in the same unit of measure. For example, change all values to feet. When asked to show work or justify your answer, don't be lazy. Write down everything about the problem, including the work you did on your calculator. Include diagrams, calculations, equations, and explanations written in complete sentences. Now is the time to show off what you really can do with this problem.
if we have right now this universal set up here where S is equal to 9, 12, 18, and I wanted to form another subset and call this subset T, and it's equal to 9, 18, 15, and 3. Oh, come on. And 3. Okay, putting them in the subset notation. Okay, and 3. We can talk about intersection of the set. So intersection. Intersection of the set. And for that, whereas we had union, where the symbol was our upside down U, in terms of the intersection, it's as if we have turned it upside down, okay? And that is the symbol we'd have been using. So if we wanted to find the intersection of S and T, the mathematical symbol we would be using in order to represent this statement would be S intersect T. All right? S intersect T. And, of course, we know in terms of our little Venn diagram here, we would have been having a set S. There is an intersection taking place. This can be S, that can be T. And so we have T with the members. We'll be looking because the intersection would be taking care of the numbers that they have in common. So in our case here, it would have been the 9s, it would have been the 18s, all right? Now, although they are in both sets, we only write it once when we're representing it on a Venn diagram. So we can have the universal set, okay? And here, in the intersection, it would be in the same position. So where they're crossing, that is where we would find the numbers 9 and 18. All right, meaning that they are common. So the other member in T would have been 15 and 3. And whereas the other member for S would have been 12. So it's on there. And that is how we would represent the intersection. But again, what were the other members for the universal set? Because we still have to take care of what we'll be calling the complements. All right? So we have 3. 6 has to be featured out here. we have 9, we have 12, we have 15. So let's look at another example here again.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read my problems completely before beginning any calculations. If you glance too quick at the problem, you may misunderstand what really needs to be done to solve the problem.
Let's extend this a little so that we get a variety. So then we can have 21 and we can have 24. Okay? Now we can have the set S and it can be equal to 3 and it can be equal to 24 and we can give it 15 too. Okay? And we can also have T and it can be equal then to our 6 and our 21 and our 9. All right? They're coming from the same universal set. So S then would be equal to our set, 3, 24, 15. And T, and notice, nothing that is in common, so there's no way we can make them intersect, because the members in this set would just be 6, 21, and 9. And so we call these two sets disjoint sets, okay? Two sets, disjoint sets, all right? So where we don't have anything that's in common, then we can call those sets disjoint sets. To tell you exactly what we have done so far, there is no intersection, so we can say that we have our disjoint sets for the universal set. And just as we said before, the other elements would have to be represented outside here. So we can have 12 here. We can also have 18, and that is what we'll do to complete that particular set here. Make certain that this looks like a U, all right? So again, just to rehearse that particular part, we have given you what is equal set, we have given you equivalent set, our Venn diagrams, the complement, intersection of two sets, the union of two sets, subsets, disjoint sets. And from before, we know the number of elements in sets. See you next time.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.